The vital role of cholesterol in brain health. Cholesterol is a fatty substance that is essential for a variety of bodily functions. About 70% of the cholesterol in your body is produced by the liver, while the remaining 30% comes from dietary sources. Cholesterol is often viewed negatively because of its association with heart disease and high blood pressure, but it's crucial to understand that cholesterol has an essential role in the body, particularly in the brain. The brain is a high-fat organ, composed of nearly 60% fat, and cholesterol is a major contributor to its structure and function. The brain's nerve cells, known as neurons, require cholesterol for their structure. Neurons have a cell membrane made of lipids, fats, and cholesterol helps stabilize these membranes, ensuring that the neurons can function properly. Cholesterol is involved in maintaining the integrity and fluidity of these membranes, allowing for effective communication between cells. The brain's ability to process information, transmit signals, and respond to stimuli is directly tied to the strength and flexibility of these neuronal membranes. Moreover, cholesterol plays an important role in creating new brain cells and repairing damaged cells. As we age, maintaining healthy cholesterol levels supports ongoing brain cell regeneration, which is important for cognitive health. The process of neurogenesis, the creation of new neurons, is heavily reliant on cholesterol, and without it, this process could be slowed, potentially leading to cognitive decline. One of the most important roles cholesterol plays in the brain is in the formation of myelin. Myelin is a fatty substance that wraps around nerve fibers, forming a protective sheath. This sheath acts like insulation around electrical wires, allowing nerve signals to transmit faster and more efficiently. Without a proper myelin sheath, the brain's ability to communicate across various regions would be impaired, leading to slower processing speeds and potential cognitive issues. For example, diseases like multiple sclerosis (MS) involve the breakdown of the myelin sheath, which disrupts communication between neurons. Cholesterol is a crucial component in maintaining this myelin and ensuring that electrical signals are transmitted efficiently. Myelination is particularly important in the brain's white matter, which is responsible for fast communication between different parts of the brain. Neurotransmitters are chemicals that transmit signals between neurons, enabling communication in the brain. Cholesterol plays an essential role in the function of these neurotransmitters. For example, serotonin, dopamine, and acetylcholine are neurotransmitters that regulate mood, memory, focus, and overall cognitive function. Cholesterol helps create the cell membranes in the brain that these neurotransmitters depend on. Low cholesterol levels can disrupt the function of these neurotransmitters, leading to negative impacts on mood, cognition, and mental clarity. Research has found that people with low cholesterol levels are at an increased risk for depression and anxiety disorders, as cholesterol is involved in the synthesis of serotonin, often referred to as the feel-good neurotransmitter. Cholesterol is also linked to memory and learning. Studies have shown that cholesterol is involved in the formation of new memories and the brain's ability to adapt to new information, neuroplasticity. Low levels of cholesterol in the brain can hinder memory and learning abilities. The hippocampus, a region of the brain responsible for memory formation, is particularly affected by cholesterol. Cholesterol supports the structure and function of the hippocampus, enabling efficient memory processing and recall. As we age, the brain naturally experiences a decline in cholesterol production, which is one reason why cognitive function tends to decline over time. Ensuring optimal cholesterol levels throughout life, particularly as we get older, could potentially slow this decline and preserve memory function. Cholesterol is also the building block for several key hormones, including cortisol, estrogen, and testosterone, which all influence brain health. These hormones regulate a variety of brain functions, such as stress response, mood, and cognitive function. Cortisol, the stress hormone, helps the body manage stress. However, prolonged stress or high cortisol levels can lead to brain cell damage, especially in regions like the hippocampus, which is vital for memory and learning. Cholesterol is essential for cortisol production, and balanced cholesterol levels help maintain normal cortisol levels, which are necessary for brain function. Estrogen and testosterone have neuroprotective effects, meaning they help protect brain cells from damage and support cognitive function. Hormonal fluctuations, particularly those that occur with aging or menopause in women, can impact brain function. Cholesterol, as a precursor to these hormones, is crucial for maintaining balance and protecting the brain from cognitive decline. Low cholesterol levels have been associated with an increased risk of neurodegenerative diseases like Alzheimer's disease and Parkinson's disease. Cholesterol plays an important role in maintaining the health of brain cell membranes, which is critical for protecting the brain from cell damage and inflammation. Some studies suggest that cholesterol may have neuroprotective effects and may help protect the brain from oxidative stress, a condition where the brain cells are damaged by free radicals. Oxidative stress is a key factor in the development of Alzheimer's and other degenerative conditions, so maintaining healthy cholesterol levels might help slow down the progression of these diseases. Moreover, cholesterol-rich diets are associated with a lower risk of cognitive decline in older adults. This is because cholesterol helps maintain brain cell communication and prevents the buildup of abnormal proteins that can contribute to Alzheimer's disease. In addition to its structural and functional roles, cholesterol is also tied to mental health. Low cholesterol levels can disrupt the synthesis of serotonin, a neurotransmitter essential for regulating mood and preventing depression. This connection is particularly important because some research suggests that very low cholesterol levels can increase the risk of mood disorders, including depression, anxiety, and even suicidal tendencies. A study in the Journal of Psychiatric Research indicated that individuals with low cholesterol levels were more likely to experience depression and anxiety. Cholesterol's impact on mental health is a reflection of its broader role in brain function and communication between neurons. While too much cholesterol, particularly the bad LDL cholesterol, can lead to cardiovascular problems, the good HDL cholesterol and cholesterol in the brain are essential for overall brain health. Cholesterol is vital for building brain cell membranes, protecting myelin sheaths, supporting neurotransmitter function, and maintaining hormonal balance, all of which are crucial for cognitive function, memory, and mental well-being. To support healthy cholesterol levels, focus on a balanced diet rich in healthy fats, including those from sources like olive oil, fatty fish, avocados, and nuts. Regular physical activity, stress management, and limiting processed foods can also help maintain a healthy balance. If you're concerned about cholesterol or brain health, it's always best to consult with a healthcare professional for personalized guidance. Understanding the vital role of cholesterol in brain health is essential for maintaining cognitive function and preventing mental health issues, especially as we age. Tell us what you think in the comments section. If you enjoyed this video, give it a thumbs up. Subscribe for more health tips.